Hi, I'm Kevin from Khan Institute of Technology. We are K20CS3007. This video we are going to see about the producer consumer problem in a classic. Uh, First, I explain the logic that the producer and consumer problem. The producer and consumer problem is a classic problem which is used for a multiple purpose of synchronization. That is synchronization between more than one process. In the producer consumer problem, there is one producer that is producing something, and there is one consumer that is consuming the products produced by the producer. The producers and the consumers share the same memory buffers that is fixed size. The job of the producer is to generate the data put into the buffer and again starting generating while job is consumed into the consume the data from the buffer. In the producer consumer problem, we use the semaphore variables. The semaphore variables, yes, there are different types of variables. A semaphore is this variable is used to achieve the mutual exclusive between the process by using the variable. Either the producer or consumer will be allowed to use or access the shared buffer at a particular time. This variable is set to be initially. The semaphore E will be the semaphore variable is to define the empty space in the buffer. In this, we are using that while function is used to produce the data again and again if it is wishes and produce again and again. The producer function is called produce data by the producer, and the waiting e will be reduce the value of the semaphore variable e by 1. That is, when the producer produces something, then there is a decreases in the value of empty space in the buffer. If the buffer is full, the value of the semaphore variable e is 0, then the program will stop its execution and no production will be done. Waits is used to set the semaphore variable yes to 0. So the no other process can append. The function is used to append the newly produced data in the buffer. Uh, let's see in this program. First, we are using the header file includes stdio.h. After that, we are giving that function of void producer to produce the data and void consumer to consume the data, and the int wait will be the function and the signal to be. Here we are using that user input as a producer consumer exit. If one we produces and producer product to the consumer, and the consumer will get from the producer. After that, we are going to return 0, and the semaphore yes will be mentioned is an yes. So int weight will be int s, and the s will be decremented if the consumer if the producer will be done means the product will be increased. The mutex will be the temporary secondary data to wait the mutex full for full signals full, and you want to get the producers produces an item and the consumers consumes an item. Let's run the program and see it out. In this first, we are just displaying that consume producer consumer exit. First, I give one. The producer produces the item one. After that, I give and the producer produces item two, item three, and after that, I asking from three will be exit. Uh, One produce item, and the two will be consumed from the producer, and there is only three items. If I give two means it will be buffer is empty. There will be containing three producers. After that, we will getting the three producers, so it will be the buffer will be the empty. After that, then we want to say second question, that reader write problem. In this reader write problem, the reader problem relates to an object such the file is shared between the multiple process. Some these process are readers. only want to read the data from the object, and some of the process are writers. They want to write into the object. The reader-writers problem is used to manage the synchronization so that there are no problem with the other data. For example, if two readers access let's access the problem, the object of the same time there may be some problem. Consider the situation of the chat between the many people. If one of the people tries to editing the file, no other person should reading or writing at the same time. Otherwise, change will not be visible to him or her. However, if some person reading the file, then other may read it at the same time. The problem parameters of this: if one set of data is shared among the process, once the writer is ready, it performs its writes. Only one writer may write an time. Uh, if the process is writing, no other process can read. So it is at least one reader is at reading, no other process can write. So first we are using that into the semaphore, the header functions. So we are creating the same underscore t and the x and comma y, and we are using the thread function to be the parameters want to running in the correct manner. After that we are using that void reader function to function, and inside the function we want to assign an variable that same weight of x, and the count will be increased if a read count equal to 1, and some weight of the post, it will be reader in the inside, and the speaker is to delaying of the time to reader didn't finish the process. So after that we want to give a condition of if reader count equal to 0, when printer is reading, reader is leaving. After that we are using the writer function, and we are using the parameters to writer is trying to enter, and the sleep 3 is to delay of the function after the writer is enter and the writer is leaving. After that we are to calling the function using the main int of n2 with the variables, and enter the number of readers to be mentioned. After then only it will be created. After that we want to create a thread or create then a writer threads of reader and writers. Let's run the program and see the output. We have only number of readers. It's delaying. That first writer is trying to enter, and the two reader is inside the program. So writer is trying to enter. First reader is inside, and third reader is inside. After that, the writer is trying to enter, and the writer is trying to. Fourth reader is inside. Writer and the five is reader is inside and the leaving. After that reader is leaving, and the second reader is leaving, and the writer has entered and the writer is leaving and the writer has entered. So the process will continue until the they will be finishing the process. Uh, After that we are going to see about that dynamic philosopher program. In this dynamic, the logic of this dynamic philosopher program, the dynamic philosopher problem states that the k philosophers seated around the circular table, and this one chopstick between each of the pair of the philosophers. There one chopstick between each philosopher. A philosopher may eat if he can pick up the two chopsticks adjacent to him. One chopstick may be picked up by any one of its adjacent fellows, but it's both. From of the problem statements, it is clear that philosopher can identify amount of time, but the philosopher starts eating when the endless cycle is time eating. The array of pi semaphore will be taken into this free thread of philosopher. Uh, that's it. Five classes are hungry simultaneously, and each of them pick a chopstick. Then the deadlock situation occurs because they will waiting for another chopsticks forever. The possible solution for this are the philosopher pick the chopstick only if both left and right chopstick are available. Uh, Allow only the philosopher to sit to sit in the table, so the philosopher can start eating. Eventually, two chopsticks will be available. In this way, deadlocks can be avoided. This I'm getting here. Uh, just in this diagram, first we are using that into that semaphore of control. So we want to given a two chopsticks at the same time, and the philosopher were hungry simultaneously. So we want to make the philosophers to eat, and the waiting for the uh, chopsticks. So they were waiting this. After this, first the fourth one taken by the class of one, the fourth two taken by the class of two, and the fifth three taken by the class of three. Till now, the philosopher completed the dinner or zero, and four was taken by the philosopher one, and the philosopher two is waiting for fork one, and the 3 is waiting for fork 2, and the philosopher 4 is waiting for fork B. Till now, the number of completed dinners are 0, and the philosopher 1 completed his dinner, and the philosopher 1 is released the fork 1 and the fork 4. So the fork 1 is taken by the philosopher 2, and the fork others are waiting. So the till the philosopher complete the dinners are 1. This process will continue until the four philosopher will eat completed the dinner. Okay, thank you.